good. All right, so we are streaming. I'm setting up my other mic, then we can get started. Right. Okay. All right, so what we'll do today is we are going to review a final exam from the last time I taught this class. Um, and if you have any questions, today would be a good day to ask your questions related to the class content. All right, so what you're seeing here, on the projector is the final exam 1 year ago when I taught this class last time. The time and the date obviously would be different. So in your case, okay, I'm pretty sure we have done this, but I cannot remember, any information from that. So we'll go ahead and check our final exam time. It's the same way that you check your final exam time for all of your other classes, unless your professor says, they are not using the originally scheduled final exam time. Okay. So the final exam schedule is here. We'll just do a quick check just so that we know what date it is going to be. So this is a daytime class. It's on Tuesdays and Thursdays. The start time of the class, I'm pretty sure we went through this last time because somebody asked me to before class, but it's okay to show you guys again. So our start time is 1:30, which is between 1:15 and 2:40 p.m. This is a Tuesday-Thursday class, so we have to look at this row. So that means our final exam is next Thursday from 12:45 to 2:45 p.m. So those people who just asked me might want to write this down, because there won't be another lecture to tell you when the final exam is going to be. All right, so we got this out of the way. Now it's time to look at the past exam. So for the most part, it's kind of like a longer version of exam 1 and exam 2. It's open book and open notes. Anything that you handwrite or print prior to the test, you can bring it with you, okay? Anything that you find, any books you find that you find useful, you can bring that with you. So in terms of material of what you can bring, kind of the same thing as exam 1 and exam 2. If you want to bring a calculator, that's fine. Okay, you can bring a simple calculator, which I think should be fine for this class. But if you think you want to bring your calculus graphing calculator with you, that's okay with me too. Okay, I don't think that's going to add any value compared to a normal simple calculator. But if that's the only calculator that you have, you can go ahead and bring that with you. No electronics other than that during the test. So no cell phone use during the test, no listening to music during the test. It's really just, the calculator is the only electronic. Okay. Now, if you want to kind of check your heart rate with your watch, I guess that's okay. So when it exceeds, like 170, you might want to calm down before you continue with your test. I'm just kidding. So that's going to be an interesting issue from here on, because smart watches are basically extensions of a smartphone. So if I cannot let people use smartphones, the smart watches, are also going to be, should also not be allowed, because, it can be used for texting and email and, a whole lot of other purposes. So we'll work that out, when we need to. The number of questions has not been determined, but we can use the past exam, as a indicator. Okay, but it's not going to be, I cannot promise it's going to be exactly the same. So do we have any questions about, the exam itself, the final exam? It's going to be 40% for you guys, because in last semester when I taught this class, they did not have a second exam. So that's why there's more weight to the final exam. For you guys, it is 40% of your final grade and not 53%, unless you want it to be 53%. I don't think people want the final exam to count more than 40%. All right, so let's go ahead and take a look at the questions. Okay, this is the first question. It is going back to the pre and post conditions, and it is asking, derive the pre and post conditions of the following algorithm. So that means you have to kind of go back and review the pre and post condition thing in order to answer this question. That was in your second exam, I think, or did we not have any pre and post questions? I don't think we have any pre and post conditions in any of our exams, so that's good in a way, because this is something that I think is very, very important. Okay, so we'll kind of go back and let me see. Yeah, we'll just go ahead and take a look at this one. So we'll go back and review some of the material for pre and post conditions. And this is a conditional statement. So the first thing you need to know is, because of the structure of a conditional statement, what can we say about the precondition of line 102 and the precondition of line 104 based on the precondition of line 101? So I know most of you cannot even remember the topic, yes? How many people still vaguely remember the pre and post condition analysis? It's okay. We got a week to study, so that's okay. All right, so let's go ahead and take a look at this. The question says the precondition of what line 101 is x does equal to n. So that's the only thing we know, okay? When we get to line 101, the only thing we know is variable x equals to n, and n can be a constant of some kind, okay? That's the only thing we know. So the first thing we can derive is going to be the precondition of line 102. So this is basically saying when we get to line 102, about to execute line 102, what do we know for sure?
X is smaller than 0.
X is smaller than 0, and
Precondition is true.
And oh, I should use. So when you write answers to this, you can just spell out and, unless you want to use the mathematical symbol. Okay, and what again?
Precondition true.
Yep. Well, and the precondition of what is true? Which one?
101.
101. Very good. Okay, so this is the template of how you derive the precondition of the entire then branch of a conditional statement. So how do we get to this part here? Because there's nothing between line 101 and line 102 that can change any of the variables. So that means whatever was true right before line 101 has got to be true, and it has got to be true at this point, because we don't have a chance to change anything. So that is why pre-101 has to be true as well. But because we're at the beginning of the then branch, and the only way to get to the then branch in a conditional statement is for the condition itself to be true. So right before we execute line 102, we know x has to be less than 0. And the precondition of line 101 is still true at this point. So when you expand this, okay, then you get x is less than 0, and this is the mathematical symbol of conjunction, or and. The precondition of line 101, which is x does equal to n, is still true. So that's pre-102. What about the precondition of 104? There's no operation, but it still has a precondition, okay? So what can you say about that line? X is greater than or equal to 0. Okay, so don't forget about the equal to, because we know the condition of the conditional statement has to be false at this point. But at the same time, the precondition of line 101 is still true, because there's nothing in between that can change the variables. So whatever was true right before line 101 has got to be still true at the beginning of line 104. So now we can just expand a little bit. So we know x is greater than or equal to 0, and x also equals to n at this point. Okay. So now what do? We look at line 102. So we can ignore the rest of the program at this point. We just look at line 102, and what type of a statement is that?
Assignment.
It's an assignment statement, which means there's a left-hand side that is getting updated, and then the right-hand side is the expression that we evaluate to produce the value to update the left-hand side. So there are two ways to derive the post condition of an assignment statement. Does anyone remember approximately what we can do? Okay, there are two ways to proceed. So what are the two ways to proceed? Yep.
I think the precondition is 101 is true. We can remove that.
No, it has to.
We can use or.
It has to do with the right-hand side. So if you look at the right-hand side of an assignment operation as a function of the variable that is getting updated, that is the first step. Okay. So we look at this expression. The left-hand side is x. So x is the variable in the function that we want to use. So you just make up a name for the function. F is fine. So what you do is you say on line 102, let's assume f of x. Now f of x is defined to be the right-hand side of the assignment, which is just the negation of x, arithmetic negation of x. Okay, so now we know what function we're dealing with. Then the next question you want to ask is this function does it have an inverse? In other words, can I undo what f of x is doing to x? And what is the inverse function of negation?
Just x.
No. It's negative x. It's minus x. In other words, this function is kind of funny in a way. It is its own inverse. Okay? The inverse of the function f is itself. Okay? So you can now say f inverse of x is also just the negation of x. Now, how do we know that applies? How can we verify that this works? One way to do it is to say, let me apply f to the inverse function of f applied to x. So what is that? That becomes the negation of the inverse of f applied to x. And what is that? It is the negation of x. Double negation cancels out, and we get x back. So whenever you have a function and you have a proposed inverse function, no matter which one you apply first and then you apply the other one and you get x back, then one is called the other one's inverse function. Now, which one you want to call as the function and which one you want to call as the inverse function doesn't really matter because they are the inverse of each other. Is that okay? Do you guys still kind of recall that conversation? Because we talked about this? Yes? Some people do, okay? All right, so now that we know an inverse function does exist, we have two ways of manipulating the precondition to become the post condition. So I'll give you a quick reminder. One is called forget. The other one is called substitution. Which one should I use here? Substitution, okay? If an inverse function does exist, then we use the substitution because the substitution method requires an inverse function. Okay, so that means now we can express the post condition of line 102. And the way we apply substitution is we apply substitution to the precondition of the same line. And then we look for the variable of the left-hand side of the assignment. And we replace every occurrence of that variable with the inverse function applied to x. So this is the template, okay? Whenever we apply the substitution method, this is the template. Once you have the template, then you can start to expand it. What is the precondition of line 102? Well, we got it all figured out a little bit earlier, which is x is less than 0 and x equals to n, okay? And we are finding all the occurrences of x, and each one should be replaced by the negation of x because the negation of x is the inverse function f inverse of x. So the next line is just doing the substitution. So once we have done all the substitution, every time you see an x, it becomes negation of x. Every time you see an x, becomes the negation of x. And that's the solution. Is that okay?
Are we looking for the post of 105?
Yes. But we have to get to the post of 102 first. Okay. All right. So post 102 is done, and then we also want to figure out what is post 104. The post of 104 is what? Line 104 does not do a single thing. So what do you think? How do you relate the post condition to its precondition?
Negative x is greater than equal to 0.
No. No.
It's still the precondition.
Exactly the same. The post condition of line 104 and the precondition of line 104 are exactly the same because line 104 does not do a single thing. It does not change a variable, doesn't do a single thing. So whatever was true right before line 104 is still true right after line 104. It's equivalent to is equivalent of not having an else branch, basically. This is just a clumsy way to say that I got nothing to do when the condition is false. So are we good so far with this? Are there any questions? No questions? Okay. So now that we have the post condition of line 102 and the post condition of line 104, we can now work on the post condition of line 105. So now we look at post 105. So because of the structure of the conditional statement, okay, so I'm going to give you a very simplified version of a conditional statement. You have a condition here. If it is true, you go to this side. If it is false, you go to this side. You perform whatever you need to do in the then branch. You perform whatever you need to do on the else branch. But the two branches have to merge before you get out of the conditional statement. This is the post condition of line 102. So this goes to here. This over here is the post condition of line 104, which is this thing here. The post condition of line 105 is what has to be true when they get to the exit point of the entire conditional statement. So what do you think?
This one of them.
It is, well, okay, that's a very vague way of specifying the correct answer. So how do we spell out the correct answer? When I'm standing here, I have no idea which way I came from, but I know that I come from one or the other.
Post 104 or post 102?
Yep, it's just the or. It's just the disjunction between the two branches. So in this case, post 105 is post 102 or, so the or symbol in math is kind of looks like a V, post 104. And then at this point, to get all of the available points, you just need to expand it. Okay, so you look at what is post 104, 102. It is minus x is less than 0, or minus x equals to n. And then you do an or, and then the post condition of 104 is the same as the precondition of line 104, and that was derived all the way up here. So we just copy that, which is x is greater than or equal to 0, and x equals to n. And that's it. We're all done. Okay? So if this is looking kind of foreign to you, you might need to study and review the pre and post condition notes and also the videos recording when we talked about pre and post conditions. So there's one question on pre and post conditions. Any questions about that? Yep.
On the test, do you have to prove that it's an inverse function?
You don't have to, but it is probably a good idea to at least mentally check to make sure that you know that that is the inverse function. Okay. Question?
From the pre-post of loop. Pre-post of loop.
We are not going to do pre and post conditions on loops because finding the loop invariant conditions of a loop is a little bit beyond the scope of this class. So we're not going to do that. So the worst we can do is with a conditional statement and possibly a sequence of assignment statements.
Assignment conditioning. Assignment and
Yep. An assignment statement is just like, what we have, on line 102, where you look at the right-hand side as a function of the left-hand side, and then you ask the question, do we have an inverse function? If it has an inverse function, you use substitution. If it does not have an inverse function, you use forget, because there's no way to kind of go backwards. All right. Yep.
What does forget do then? What does forget do then?
Forget. So what forget does is you remove certain expressions from the precondition because you have no idea whether those conditions are true or not anymore. So you just have to remove the components that mentions the variable that was changed because of the assignment.
So we use the new variable after.
Huh?
We use the new variable after the forget.
So you state that the variable equals to whatever is on the right-hand side of the assignment, as an addition condition after the forget.
Okay.
Yep.
So are we allowed to use nodes?
Yes, it is open book and open notes. So you can potentially print, all of the notes that I have, all the modules that I have written, all the sample programs that I have written. You can even go to the video recording, like, what you see on the screen right now, and just pause the video, take a screenshot, print it out. That's perfectly okay. Yep. So anything that is printed or handwritten prior to the test is fine. Okay. So all the spreadsheets, that I have worked out in class, you can bring those with you as well.
None of them help. None of them help. Trust.
No comments. They will help. Okay, so the material that you bring with you is helpful if there's some details that you do not trust yourself that I can remember all of the details. Okay, so it will be helpful to do that sort of thing. Like, okay, I have no idea what this symbol is. Okay, well, it's already introduced in one of the modules, so you can bring the print out of the module so that you can look it up. Okay, or you might forget what is a mod operator. Okay, but the mod operator was actually explained in one of the modules. So if you bring the print out of that module, then you can look it up and find out, oh, okay, the mod is really just the remainder of a division. Or you may forget what is a floor. Okay, what does it mean when we apply the floor function to something? Okay, that was explained in one of the modules too. Okay, so you can bring all the modules or print out of the modules. But the problem is, if you do not read the modules ahead of time when you're studying, and you know that it is there somewhere, then you're trying to find a needle in a haystack. Okay, that might take you a long time. So the idea is, as you read the modules to study and prepare for the class, you can use Post-its. Okay, use little Post-its and say, okay, this is where floor is defined. This is where mod is defined. This is where we talk about the forget rule. This is where we talk about the substitution rule. This is where we talk about what to do with the conditional statement in a pre and post condition situation. So you have little Post-it to help you quickly locate important information. So you don't have to go through pages and pages and pages of material just to find one definition. So it is still helpful, okay? But it is only helpful if you already know what is in the module and have a quick way to index into those definitions. Okay, so are we good with this question? Okay, all right. We can always come back, in case someone has some additional question. Okay, this is number 2. So number 2 says, trace the following algorithm. In the precondition, assume A is an array of 7 elements initialized with a student ID where the leftmost digit is in the first element. Okay, so let's go ahead and work with this one. And you can see this one has no subroutines, right? So without subroutines, you can kind of predetermine how many columns it's going to need because it's not dynamic. You don't need additional columns. You also do not need to name the columns because without subroutines, there's no way to pass something by reference. And if you're not passing something by reference, there's no need to name a column because you don't need to say, oh, refer to column, blah, blah, blah. Okay, so we do have conditions here. So we do need a column for comments. And the amount of space you need for comments basically is limited by how big of, how long the conditions are. The longest one is right here, so we just need to leave that much space depending on how small I can write. Then we have the usual line number, and without return info and all the crazy stuff you have to do with return info, line number is just a number, so it doesn't take up a whole lot of space. Now we have to move on to global variables. So every single variable in this case is global because nothing is contained inside a subroutine. So we have variable I, we have variable x, and we have variable a. Now a is kind of funny because a is an array. So as an array, it has 7 elements because that was given in the question that it has 7 elements. So we'll say this is element 0. It has its own column, element 1, element 2, element 3, element 4, element 5, element 6, and that's it. Okay, the last element is indexed 6, not 7, because we started counting from 0. Okay, so this is something that you have to be careful. All right, so now we have to state the precondition. I, we know nothing about it. X, we know nothing about it. And then the content in the array depends on your student ID. So I'm just going to use a fictional student ID in this case. The leftmost digit is element 0, okay, being the first element. So we'll just kind of imagine that we have a student ID of 1, 7, 4, 5, 0, 9, 1, okay? I hope it doesn't coincide with one of your student IDs, but I hardly doubt that will be that coincidental. All right, so this is the precondition. On line 172, we put a 0 into I. On line 173, we put a 0 in variable x. On line 174, we evaluate the condition. Is I less than bar a bar? And it is true. Then on line 175, we ask the question, if you look at a bracket I, and you mod it with 4, is the result equal to, does the result equal to 0? So this time we have to kind of slow down a little bit and take a look. Huh? Is mod 2? Oh, okay. I misread it as 4. So let's change that. Mod 2, does it equal to 0? So now we have to say, is it true or false? A bracket 0, because I is 0 at this point, so A bracket I is referring to A bracket 0. It has a value of 1. 1 mod 2 is 1. 1 equals to 0 is false. So we say, nope, it is false. Then we go to the else branch, which is on line 178. On line 178, we are subtracting that amount from x. So we are subtracting 1 from x. X is now negative 1. Like that. Then we get to line 180. We add 1 to I. I goes from 0 to 1. Then we get back to the beginning of the loop. Okay. I is less than bar a bar is true. And then we go to line 175. A bracket I, which is A bracket 1 this time, mod 2 equals to 0 is false. Because 7 mod 2 is 1. So, we do the same thing again. We get to the else branch, which is on line 178. We add the negation of that particular element, which is 7, to x. So x is now negative 8. We get to line 180. We add 1 to I goes from 1 to 2. Then we go back to line 174. So we basically just do this like, 5 additional iterations. So are there any questions about this one, or do you guys want me to finish it? Okay, fine, we'll finish it. Okay, so I is less than bar a bar is true. A bracket I mod 2 equals to 0 is. So we are talking about a 4. This time it is true. So we go to line 176. which is adding, okay? So I can cheat a little bit here, even though I'm using Zerno, because it has a ruler tool. Yeah. So this also means that you might want to bring a ruler with you, or if you prefer, you can also bring graph paper with you and just do all your work on separate sheets of graph paper. That makes the lining up everything easy, okay? And then just staple everything to the exam when you turn it in. Okay, so that's definitely an option. All right, so let's go back to, we don't want to use this tool. Okay, so now we go to, so let's go back to line 176. So line 176 is just adding the element to variable x. So this time we're adding 4, so now negative 8 becomes 4. We get to line 178, we add 1 to I goes from 2 to 3. Then we get back to line 174, I is less than bar A bar is true. We get to line 175, A bracket I mod 2 equals to 0 is false, because 5 mod 2 is 1, and 1 equals to 0 is false. So that will bring us to line 178. We subtract 5 from x, so that means it's going to be, oh, this is negative 4. So negative 4 minus 5 is negative 9. Then we get to line 180. We add 1 to I, goes to 4. Then we get back to line 174. I is less than bar A bar is true. 175. A bracket I mod 2 equals to 0 is, okay, I have to scroll up to find out what it is. This time it is 0. 0 mod 2 is 0, so 0 does equal to 0 is true. We get to line 76, we're adding 0 to x, which really doesn't change anything. Then we get to line 180, we add 1 to I goes from 4 to 5. We get back to 174, I is less than bar A bar is true. Okay, we're getting there. Okay, we just need maybe just a few more rows. Because it is true, we get to the next line. A bracket I mod 2 equals to 0 is, okay, so we are looking at A bracket 5. It is 9. 9 mod 2 is 1. 1 equals to 0 is false. So we go to the else branch again, which is on line 178. We subtract 9, in this case, from x. X is now negative 18. We get to line 180. We add 1 to I. We go back to line 174. I is less than bar A bar is true for the last time. And then we go to line 175. A mod 2, A bracket I mod 2 equals to 0 is false, because A bracket 6 has a value of 1. 1 mod 2 is 1. 1 equals to 0 is false. So we go to line 178, which is the else branch. We subtract 1 from x, so x is now negative 19. We get to line 180, we add 1 to I goes to 7. We go back to line 174, I is less than bar A bar is finally false. Then we get out of the loop and get to post, and we're all done. In other words, it goes through all the digits of your student ID, we add all the even numbers, and we subtract all the odd numbers. That's basically what the program does. So are we good with this one? Okay, all right. So moving on, next question. Oh, okay, just scrolled a whole bunch more than what I needed. All right, so this is question 3 of 5, and we're supposed to trace it. Okay, so before you trace it, okay, the first thing we need to do is just to kind of visually go through it, especially the one line that looks really awful, okay, which is line 199 in this case. So we're printing something. Whenever we print something, we just have to indicate in the comments column that we're printing a particular value when it is printed. So, but we cannot do any printing until we have figured out what value we are printing. Okay, so the parentheses play a very important part here, because we know that invoke v3 is on its own. We just invoke it, get a value. Okay, that makes the left-hand side of a subtraction. But the right-hand side of the subtraction is a little bit more complex. It really is the return value of v2, but I cannot invoke v2 until I know what value I need to specify for parameter x of v2. So after I'm done with invoking v3, the next thing I need to do is to invoke v1. Whatever v1 is returning as a value becomes the value of parameter x when I invoke v2. When v2 is done, then I have both the value on the left-hand side and the value on the right-hand side of the subtraction, carry out the subtraction, and then just print that value out. So that's the general idea of the sequence of doing things. One thing you do have to remember is you can only invoke one function at a time on the same line, okay? So that means you do not want to see multiple question marks as you trace this line here, okay? All right, so knowing all of that stuff, would anyone mind if I use a spreadsheet to trace this, or do you still want me to? Because you cannot use a spreadsheet. I just want to be equitable and use hand tracing. But in the grand scheme of things, of just explaining things, a spreadsheet is a little bit faster, and also I don't have to go back and forth between the trace and the code, the trace and the code. Okay, so I'm going to use a spreadsheet to speed things up a little bit. All right. So I'm going to keep the same line numbers, and I'm going to hide line, well, actually, I can do it this way so we can actually see the whole thing. And we'll zoom out a little bit. Okay. All right, so with this one, I still do not, well, I need comments only because of the printing. Then we have line number, and then we have no global variables in this case. So before you can start tracing, you have to figure out, are there global variables that we need to allocate columns for? So we start with subroutine v1, okay? v1 doesn't have any local variables, has no references to names of any kind, so that one is fine. We look at subroutine v2, okay? v2 does have a reference to a name called x, but x is a by-value parameter, which means x is not a global variable. So we don't have any global variable up to this point. We look at v3. v3 does not refer to any names, so there's no need for any global variable to exist. We look at main. Main also does not have any reference to any type of name. We're not storing anything into any particular name. So main also does not have a global variable. So that means the entire program does not have a global variable. So that makes things a little bit easy, because when we look at the precondition, there's nothing to say because there are no global variables whatsoever in this entire program. We start execution on line 201, so we get into main. And we have to remember to store the return line number, which is post in this case, but there are no additional columns that I need to allocate because main does not have any local variables, nor does it have any parameters. So now we just continue execution on line 199, which is going to be the messy line, okay? This is going to be super messy. Because on line 199, we have to invoke things a few times. There'll be 3 invocations from line 199 in this case, but you can only invoke one at a time. So we have a choice, okay? We don't have to start with v3. We could easily start with v1, okay? That's fine too. Which one do you want to start with? v1? Okay, we'll start with v1 then. Okay, so if that is what you want to do, okay, you basically have to copy the entire line, okay? So in the test, do not abbreviate this part, okay? Just copy the whole line except for the invocation that you're taking care of. So basically, you just write the entire line here. Print invoke v3 minus invoke v2. Now, this is the invocation we are trying to deal with. That is why it is replaced by a single question mark. But everything else, we just type exactly the way it looks on that particular line right now. Is that okay? Okay. So this is what I mentioned a little bit earlier. You only have one invocation. You can only invoke one thing at a time. So you cannot have multiple question marks when you create this return info. So this is the return info here. Okay. And we'll make this wider. V1 does not require any parameter, nor does it have any local variables. So we don't need to allocate any additional columns. So we go into subroutine V1, which only has one line that is useful on line 187, and it says return 6. Now, I do understand that time is precious in the final exam, so in the exam, okay, instead of copying and pasting and replacing the question mark, you can just cross out the question mark and write down, in this case, 6. So that will significantly save your time in the exam. Does everybody understand what I just said? Okay, no? Okay. It's difficult for me to do it here, so let me do it once on the projector, on the whiteboard. So this part cannot be recorded just because I'm doing it this way. So in the exam, okay, you still have to write the return info like this, but when we get to line 187, you can just say 6 goes here and cross that out. Is that okay? Because that is sufficient for me. I don't want you guys to waste the time to rewrite the entire thing only to replace the question mark with a single value. This gives me just as much information to confirm that you understand how to run the return statement. So is that okay? Because I think this will save a huge amount of time, so that you don't have to copy and paste a whole bunch. Is that okay? All right. So I'm going to continue with this just a little bit because there's another notation I want you to consider using for the final, so you don't have to copy and paste a whole lot of stuff. So after line 187, we get to line 188. Line 188 doesn't do much. All it does is to deallocate these columns, okay? This one single column in this case. So now you just say return info, cross it out, okay? You do still have to say that because this is how I know that you're deallocating a column. Now, if you want to say, I don't want to write return info and then cross it, if you just cross it here, it's fine, okay? I understand that this means you're deallocating the column when you get to line 188, okay? So once again, that is done so that you can save time when you're doing this on paper. Are we good so far? The next one is big, okay? The next one is, what do we do next? After line 188, we use the return info cell to tell us where we are going back to. So what you can do now is really just to go this, okay? But the problem is, when you do something like this, you have to remember that this question mark is really gone. It really is a 6 in place of the question mark when you move on to continue your trace. Is that okay? So this will save you a lot of writing, in the exam on a piece of paper. But it's difficult for me to document this when I'm using a spreadsheet. Is that okay? All right? All right. So for the rest, I'm just going to continue with a spreadsheet, but now you know the shorthand of how to do this, okay? Question? Oh. All right, so 988. So when I do it on the spreadsheet, I'm still going to do it the same way. Okay, wrong place to put it. The question mark is now a 6. And on line 188, return info is deallocated. Then we get back onto line 199. And 199 is now looking like that. I think there are ways to insert shapes, like arrows. Nope, I don't think that is what I want. I think it's a line, and then we can change the line to have arrows. So we can kind of do it like that. And then we can specify the end. Nope. I'll try one more time and then we'll continue with the class. So let's try to insert shape arrow. Okay, that might work. Nope. Because it really just want to draw a right arrow. Okay, I'm not that good with drawing shapes inside a spreadsheet. Okay, fine. So we'll copy and paste. There we go. All right. So this is what line 199 looks like now. It is a little bit simpler than before. So right now, we also have a choice. You can now call V3 if you want to, but we also have everything that we need to call or invoke V2. So once, yeah, go ahead.
We can just like draw an arrow to the way where we're gonna put it in, just like a copy and paste.
Yeah.
Instead of writing it, so just save us some time, right?
Yes. Okay. So the whole idea is, that will save you time. Yeah. Yep. But you still have to kind of indicate. Yeah. So in your case, it's going to be drawing an arrow from here to here, but also at the same time you have a 6 to point and cross out the question mark. Okay. So now we are looking at line 199 again. It looks like this. We look at this and go like, we cannot print anything yet because I cannot do the subtraction yet. But we do have a choice of invoking V3 right now or invoking V2 right now, because both can be invoked. I got enough information to invoke either one. So it's up to you. Which one do you want to invoke? Two? Okay. You guys like to do things kind of backwards, right? And trust me, the compiler does that too. By the time you get to cisp300, you'll know what I'm talking about. Okay, so that means I have to reallocate this column for return info because I'm invoking V2 this time. So, and then the return info says, okay, we still have the print, we still have the invoke V3, we still have the subtraction, but the right-hand side of the subtraction is the invocation that I'm taking care of at this point. So that entire invocation is replaced by a single question mark. But in addition to return info, I also need an additional column because V2 has one parameter. Okay, so it has parameter x, and okay, x goes here. Parameter x is passed by value. So that means this 6 here is used to specify the start value of parameter x, and this is how we set up column E because it is the parameter. Are we good so far? Okay. Then we continue execution in the subroutine, which is on line 192. So on line 192, we have to compute x minus 13, which is 6 minus 13, which is negative 7. So now, on the written form, you can now just write down, a 7, negative 7, and then point it to the question mark and cross out the question mark. Okay. Now, where you write the 7 has to be on the line where the return is. Okay, because I need to know that you know how to execute a return statement, that the return statement is the one responsible to change the question mark to a specific value. So that part has to be, it needs to be like that. You cannot just kind of cross it out at some random location. Okay, but since I'm using, okay, I just hit the wrong key. Okay, since I'm using a spreadsheet, I'm just going to do it the usual way, copy, paste, and modify. So I change the question mark to negative 7. Then we get to line 193, which deallocates this column, but it also copies and pastes the return info cell, so we know when we get back to line 199 what else we need to do. So right now we only got one invocation left. Okay, so you don't have a choice anymore because we only got one thing that we can invoke, which is V3. So we have to reallocate column D for return info. And this time we're just invoking v3, which does not have a parameter. So 100, so the return info is line 199. We still have the print, but this part is now a question mark. The other side is already known to be -7. Do we have any questions about this part? Okay. Then we move on, continue to the first line of subroutine v3, which is on line 196. That's just returning a value of 32. It's a constant that we are returning. So we replace the question mark to 32, and that's it. You do not carry out the actual subtraction at this point, okay? The whole purpose of the return statement is just to change the question mark to a specific value. So in other words, we don't collapse 32 minus -7 is 39 at this point, okay? So do not replace the whole expression to 39 because we are only changing that question mark, okay? And then what do? We get to line 197, which once again is deallocating this column again. And then we copy and paste return info onto the line number column. So now when we look at line 199, go like, okay, we know what to do now. Because 32 minus -7 is 39, and we're just printing 39. So we can just say print 39. That concludes line 199. We get to line 200, which is returning from main to post, okay? So we still have to visually show that column C is deallocated at this point. And then we move on to post because that's what return line number the columns tells me to go back to. And now we're all done. So are we okay with this trace? Okay. Does anyone need clarification of what shorthand you can use in the test? Or are we good with that? Okay. All right. So we are moving on to the last question. Oh, question 4, second to the last. Okay, so question number 4 is recursive, which means you might want to use a piece of paper and use it sideways in landscape mode because it might need a whole bunch of columns. So we look at this code, and then once again we have to first analyze it a little bit before we draw out the columns. We are referring to I, but that's okay. I is a parameter. Sorry? Oh. We look up J, and it's okay because J is also a by-value parameter. So I and J cannot be global variables because they're all defined locally. And on main doesn't use any variables at all, has no reference to any particular name. So we are all good. There are no global variables again. Okay, so that means we can start the trace. So let me go back to here. All right, so we'll go ahead and trace. Where's my? Okay, there we go. That's the code, and here's the trace. So we start with. We do have conditions, so we have a comments column for the condition, line number, no global variables, so the precondition has nothing to say. We start execution on line 136, which is just invoking main, so we need a return line number. The reason why we use a return line number instead of return info is because main does not return a value. There are no return statements inside main. Okay. And then we move on to line 134. So now we look at line 134. This one is not nearly as complex as the other one because there's only one single invocation. The complexity of question number 4 comes from recursion and not so much we have multiple invocation on the same line. So now we need to invoke F1. Okay, so we need a return info because it does return a value. And then we say, when we get back, we have to go back to line 134, and whatever the invocation is returning is whatever I'm going to print. So this is what we need to do for return info, which is a lot simpler compared to question number 3. But then we also have to pass parameters. This parameter I, parameter j. I is 64 and j is 4 in this case. So that's how we set up additional columns for the first invocation of subroutine F1. Then we get into subroutine F1 starting on line 128. We evaluate the condition first. I is less than or equal to 1 is false. So we go to the else branch, which is on line 131. On line 131, it is a return statement. As a return statement, I would love to specify the return value, but I can't because the return value itself is 1 plus and then the invocation of F1 again. So I have to do the invocation again. So this is the recursive call. All right. So this is where things can start to get a little bit confusing, but it doesn't really change the nature of how we invoke a subroutine. So we say return info. When we are done with this invocation, let's go back to line 131 because we still have to return 1 plus whatever the invocation is returning. So are there any questions about how we set up the return info in this case? Okay. And then we need to specify parameter I and parameter j. Parameter I is I divided by j. So you can see I is 64 right now. So 64 divided by 4 is 16. So this is 16. J is just j itself. Okay, we're passing j as is, which is 4. So this is how we set up the second invocation. And then we go in here. We go to line 128 again. I is less than or equal to 1 is false because it is 4 at this time. We go to line 131 and we basically do about the same thing. Return info is still going back to line 131, and what is left to do when we get back looks exactly the same as column G. Okay, and then we have to set up I and J again. I and J. J is passed as is, so it's always 4. I is 16 divided by 4, so we just 4 just 4 this time. Okay. So now we go back to the first line in the subroutine, which is on line 128. X is I is less than or equal to 1 is false because it is 4 this time. We go to line 131, and it's kind of the same thing. We have return info again. When we get back, we have to get back to line 131 and return 1 plus a question mark. Parameter I this time is 4 divided by 4, which is 1. Parameter j is always 4, just like that. So this time when we get to the first line, which is 128, the condition is going to be true this time. Okay, so when we get back to line 128, I is less than or equal to 1 is true. So now we have to go to the then branch on line 129. Let's go back to the source code and find out what is on line 129. Okay, not that. Nope. There we go. Which is just returning 0. Sorry?
I have a question.
Yeah.
The condition is like, it looks like a condition is not loop, but
It is a loop in a way, but it's not exactly a loop either. Okay, because a loop would not use additional columns. So this is not exactly a loop, but it is doing what a loop would normally kind of be able to do. Okay.
confusing for me how to.
Well, the idea is, you just look at an invocation like an invocation. Yep. So you use exactly the same mechanism whenever you invoke a subroutine. So now we are returning 0. 0 is a constant, no big deal. So, once again, you can use a shorthand in the test. Just write down a 0 on row 17 this time, and then use the 0 and point it to the question mark and cross out the question mark. Okay. And then on line 130, it is the end of the subroutine. Nope, I take it back. Line 29 goes all the way to line 133, which is the end of the entire subroutine. Okay, let me show you that. Because we just executed line 129, which is the then branch of the conditional statement. So once you're done with one of the two branches of a conditional statement, you get out of the entire conditional statement. The entire conditional statement ends at line 132, so that's why we are jumping onto line 133 at this point. So what we do is we deallocate all the columns for this particular invocation. And then we copy and paste the return info. So once again, when you're doing this in the test, you can just draw an arrow from here all the way to here. Okay, so I will understand that you know which column or which return info to use in order to specify where you go back to continue execution. So now we are actually on line 131, and we know what we are returning this time. So on row 19 of the trace, when we execute line 131, we know we're just returning a value of 1. So we'll go ahead and execute it, which means we look up the rightmost in-use column labeled return info and replace the question mark with the value of 1 this time. Okay? So the rightmost in-use column that is return info is column J. So with a spreadsheet, I can do this, okay? And then we replace the question mark with 1 because that is the value I'm returning on line 131. So this looks confusing. Yep.
I got a question. After line 129, go to line 133 or 35?
That subroutine doesn't have an end effect.
Oh, I forgot the end defined sub. There should be one end defined sub here. Thank you. We'll call that line 132 and a half. Okay, so I messed up the source code. Okay, there should be a line in between those two that has an end defined sub. So we'll pretend that line 132 and a half is end defined sub. And I can actually do that here. There we go. So I just inserted a line to end the definition of the subroutine. So now we're back to, we're done executing line 131 and returning a value of 1. So this may be the most confusing part of recursion and also having an invocation on the same line as a return. Do we have any questions at this point?
If you have instead of 0, like 5, 6,
Say that one more time.
and plus of 0, we are returning this different number, like it's 9, 5, for example. Then you have to add with 1.
I'm not quite sure what you're asking.
No, it's 1 plus 0. So
Yeah.
what if it is 1 plus 2,
Plus 2 plus 5.
If this is 1 plus 2,
for example?
Yeah.
then you're returning a value of 3, right? So you look up the rightmost in-use return info column, copy and paste the cell, change that question mark to 3. Is that okay? So it has to do with the ordering and also the rationale of what we are doing. Okay, so just taking a screenshot here is not going to help. You really have to understand the mechanism and why we are doing it this way. Okay. All right, so that being said, what line 131 is done, and we are moving on to line 132 and a half, because that's the line that okay, it's going to come back. That's the line that we inserted. There you go. And once again, we have to deallocate the columns. Okay, so I can just copy and paste it. You kind of have to just do a long stroke across that line, to indicate what columns you're deallocating. And then we copy and paste the return info cell here. So now we are getting back to line 132. But this time when we get to line 132, this is what we're executing, okay? Cell B21 tells us what we are doing, okay? What are we doing? We're returning a value of 2 this time, okay? What is the mechanism of returning a value of 2? We look up the rightmost in-use column that is still labeled return info, which is column G. We copy and paste and change that question mark to the value that we're returning. So we are going to copy and paste G9 and replace the question mark with the value that we are returning, which is 2 in this case. Okay, so this is the most confusing part if you're just looking at a screenshot. But if you understand the steps of doing it, it should not be confusing at all. Now we get to 132 and a half again, which is the end of the subroutine. So once again, we deallocate a whole bunch of columns, and we get back to line 131. And this time we're returning a value of 3. So what do? We look up the rightmost in-use column that is labeled return info, and we're down to column D this time. Copy and paste it. Change the question mark to the value that we are returning, which is 3 this time. And then we move on to line 132 and a half. That means we have to deallocate all the columns for this particular invocation, and then we copy and paste the return info cell into the return line number. And this time we say, oh, okay. When we get back to line 134, it just says print 3. Well, we can print 3. So we're just printing 3 to a screen, to a printer, or whatever. And then after that, we're done with main. We get to line 135, which then has to look up the rightmost return line number column, which is column C. Column C says, let's go back to post. Okay. We go back to post. And remember to deallocate return line number, the column. And we're all done. So we get back to post. Do we have any questions about this one? No questions? Okay. All right. So let's move on to question number 5. So here's question number 5. Looks a little bit long, but it's not that bad. Okay, we'll get through this. This one has records. Okay, and that's why it is a little bit long and kind of cumbersome. Looks cumbersome. So let's try to figure out what it's doing. We got about 12 minutes left. I think we got enough time to do this. So a record, in this case, is representing a fraction. A fraction has a numerator and a denominator. Both are integers. Subroutine S1, has one single parameter, which is f. It is a fraction passed by reference. It has a local variable I. I starts with 2. And there's a loop here. Inside the loop, there's a conditional statement, blah, blah, blah. In main, we have a local variable that is a fraction. And for that particular fraction, the numerator is 54. The denominator is 90. So we want to find out what the subroutine is doing with this particular fraction. Okay. So do we have any questions about the concepts of this code before we start to trace it?
X is the fraction, right? X is the fraction in main.
Yes, X is a local variable of main, and the type of X is a fraction. It is a record type. Okay, so now we look at the trace. Okay, start a new sheet. We do have conditions to evaluate. This time we do have long conditions to evaluate. We have line number. There are no global variables. We start on line 147, which needs to remember where to go back to, which is post. But it also has a local variable this time called x. X is a record type. It has got 2 components. It has got a numerator and a denominator. So that's why x is actually officially using both columns. But because it is a local variable, They both start with unknown values like that. Do we have any questions about how we set up the columns when we invoke main on line 147? Okay. Next, we move on to main. Okay, line 143 is initializing n as a member of x to be 54. And then the next line initializes the denominator d to 90. And then we invoke the subroutine on line 145. This particular subroutine does not have a return, so return line number is fine. We just return to the next available line, which is line 146. But we have one parameter. We have a parameter f, which is a pass by reference parameter. So anything that is passed by reference is only going to use one single column. Even if it is a pass by reference variable, parameter that is of a type that is a record that is huge, it only uses up one single column because it is a reference to the columns. So in this case, it is a reference to columns D and E. Okay, and that's how we set up F. It also has a local variable I, which is just a regular integer. It takes up its own column, and it has an unknown value to begin with. And then in the subroutine, we start with line 131. I is initialized to 2. On line 132, we have a conditional statement, a condition to evaluate. F dot n is referring to column D. It is 54, and 54 is greater than or equal to I, which is 2, is true. And then we have to evaluate the other one. F dot D, which is 90. 90 is greater than or equal to 2 is also true. So both of these are true. So that means the conjunction is true. Are we doing okay so far with this? I can share the spreadsheet with you. Okay, so this way, we don't have to use up all the column space to display the condition. So we get into the loop.
Aren't they greater than or equal to the I?
They're both greater than or equal to I. Oh, okay, I see. I has a value of 2, that's why I said 2. Okay, and 2 over here, 2 is just I. Okay, then we move on to line 133. Okay, so we look at f dot n, which is 54, mod I, which is 2. Does that equal to 0? Yes. Okay, the remainder of 54 divided by 2 is in fact 0. So this is true. What about the other part of the conjunction? Is that true? In other words, we're looking at the denominator, which is 90. 90 divided by 2 has a remainder of 0, is true as well. So now we have true and true, which is true. And so we move on to the then portion of the conditional statement, which is on line 134. So what do we do on line 134? Well, we have to evaluate the right-hand side first. So the right-hand side is really just saying, okay, let's take the member n of the record that f is referring to, which now has a value of 54, divided by I, which is 2 at this point, so we have 27. Then we store 27 back to member n of the record that f is referring to. So that is, whatever column is storing the 54 right now. So this is really the important part. If I don't have enough time, this is the key of the entire thing. Okay, we are changing column D at this point to 27. On line 135, we do the same thing to the denominator, so that becomes 45 at this point. Do we have any questions? Nope. Okay. Then we get out of the, no, we don't get, we get out of the conditional statement. We go back to the beginning of the loop, which is on line 132. And that whole thing is still true because I is still 2. 27 is greater than or equal to 2 is true. 45 is greater than or equal to 2 is also true. So that whole thing is still true. So I'm gonna, oops, save a little bit of time here. Okay. And then we move on to line 133. This one is false, okay? Because if you look at f dot n, which is 27 mod 2, I is 2, that thing equals to 0 is false. Because 27 mod 2 is 1, 1 equals to 0 is false. So because of short-circuited evaluation, this is where you can say the whole thing is false. I don't need to look at the other side of the conjunction. So that would make us go to line 137. We bump I up by 1, so now it is 3. We go back to the beginning of the loop, which is line 132, and obviously both are still greater than or equal to 3, so that whole thing is still true. Because 27 is greater than or equal to 3, 45 is also greater than or equal to 3. Yep.
Is there a way to shorthand that?
You can probably just pull something that you have written earlier and just make an arrow to that cell and say that I'm just copy and pasting the entire thing. So yes, so you can do that, do it that way. Okay, so we are now on line 133. So we are asking, basically, do they have a common denominator of 3 between 27 and 45? The answer is yes, right? So you can copy and paste, okay? In other words, in written form, just draw a big arrow and just go like land it that way. But I pulled the wrong one. I should be pulling this one, okay? All right, so you can see on the top here, now it is correct, okay? So when the condition is true, we go to the then branch, sorry?
So for the other part after d mod I equals.
Oh, equals to 0 is true. Okay, there we go. And this one needs to be fixed too because I just copied it from there. There we go. So now we go to line 134, which divides 27 by 3, which is 9. And then on the next line, it divides 45 by 3, which is 15. Then we get out of the loop, go back to the beginning on line 132. That is still true because they're both great. 9 and 15 are both greater than or equal to 3. And then we move on to line 133. And that condition is true as well because 9 and 15 both have 3 as a factor. So that condition is still true. So we go to line 134. We divide 9 by 3. It is 3. We go to line 135. We divide 15 by 3, which is 5. And then we get to line 132 again. And we ask the question, are they both greater than or equal to 3? Yes. The answer is yes. Okay. Then we move on to line 133 and ask, are they both having 3 as a factor? The answer is not true, but you cannot short circuit it this time because f dot n, which is 3, 3 is still a factor of 3. So the first condition is still true. It's the second condition that makes the entire conjunction false. So when you're writing this, you cannot shortcut it this time. So because it is false, because it is false, we move on to line 137, which adds 1 to I. I goes from 3 to 4. Then we get back to line 134. So this time, this condition is false because f dot n, I copied and pasted the wrong thing. Oh, I've been copy and pasting the wrong thing for a while. Okay, fixed. Okay, there we go. One more time. One more time. All right. So this time the answer is false because if you just look at the numerator, the numerator is now 3, I is now 4. So we just say that that part is false because we can short circuit this entire thing. So we're almost there and we still have a few seconds. So we get out of the loop. Okay, when we get out of the loop, we get to line 140, which is the end of the subroutine. So that means we are ending the call to S1. So we deallocate those 3 columns. And then we use the return line number to get back to line 146. And then on line 146, we deallocate these 3 columns and then return to post, and we are done. So basically what the subroutine is doing is it is simplifying a fraction. Who said that? That was good. Did you guys see that though? I mean, when as we trace through the algorithm, did you guys see that it's actually just simplifying the fraction? Yep. All right. So I just have this one last thing to do, but you guys can go if you want. Okay, there we go. So I will share this document with you. If you don't see it, in the announcement, just send me an email to remind me because I have to leave now to pick up my kids.